All right, guys, welcome to the video. This is chapter, Chapter 7, Electrical Systems. All right, we're not going to make you an expert. What I'm just going to do in this one here is just go over a few definitions and then maybe a few concepts. These definitions and concepts are directly what's going to be on your homework, or whether it's the quiz or the assignment. So I know some of you are having a hard time getting the book or dealing with the online format of the book. If you watch this video, you have all the information you need to do your homework. All right, all your homework. Okay. So, unfortunately, because of that's the way I'm doing it. The order might not make a lot of sense, but just bear with me. Everything that you need to know will be covered. Okay. So the first thing I'm going to talk about is some definitions. All right. We're going to talk about Ohm's law. Ohm's law is basically an equation that was created in order to figure out electrical pressure. That's it. Okay. The formula is volts equal amps times ohms. Okay. Volts equals amps times ohms. That's all you need to know about that. Okay. Now we're going to talk a little bit later about what a volt is and an amp and an ohm and all that. But for right now, Ohm's law is basically measuring a way to calculate electrical pressure, and it is done by volts equals amps times ohms. So if you have amps and ohms, you can figure out your volts. If you have volts and amps, you can figure out your ohms, and vice versa, right? By changing the formula. Okay? So let's talk about alternating current and direct current. Alternating current is just basically ways how electricity is delivered, okay? Or used, actually. Delivered, I guess, is the best way to do it. Say it, the type of current that there is. All right. Now, in a house or a facility, the wall electricity is AC. Okay. When you have something like that's powered by a battery, that's DC. All right. So AC is alternating current, and DC is direct current. Alternating current is where the polarity alternates from positive to negative. And then there's good pictures of that in the book if you have the book. Okay. And then direct current is where the polarity remains the same, either positive or negative. Okay. So that is the definition of those two. Okay. So next we're going to talk about a piece of equipment called a transformer. The transformer is a device that increases or decreases the voltage of an electrical current. All right. That's all it does. It increases or decreases. All right. Then we're going to talk about a circuit breaker. Now, a circuit breaker is something that you need to know about. It's all in everybody's houses, and this is something that you're going to deal with in the hospitality facilities. Is their overcurrent device in a breaker panel? Basically, if too much amperage is drawn from appliances or on a circuit, it breaks the circuit. Right? Electricity just stops, and you have to open up those gray metal doors, look at the circuit breaker, and reset the circuit. And generally speaking, you have to reduce the amount of draw on that circuit, right? So that is a circuit breaker. Okay, let's see, I've got all of those. So now we have what the book calls a ground fault circuit interrupt, all right? Most of us, it's colloquially known as the ground fault interrupter, right? When I was a kid, there was no such thing. When I was in high school, they started these things. And basically, when you have outlets, wall outlets, that are close to water and things that can be dangerous, it's basically just a little circuit breaker at the plug. And you've all seen them. They have the two plugs, top and bottom, and in between there's two little square or rectangular buttons, and if it trips it right there. All right, so that's more immediate. It's much more safer. Instead of having to go all the way to the circuit breaker, it's right there where the appliance is plugged in. So if something's going on, it's a danger to the human being that's using it. It trips it right then and there. All right. The definition, the textbook definition, is a type of electrical receptacle that provides added protection against electrocution used in wet areas. All right. That was probably a much simpler explanation than what I gave. All right. So an uninterruptible power supply system provides continuous clean power to electronic devices during power outage or other events with power quality problems. And we're going to talk about power quality later. All right, these systems generally operate on for only short periods of time and do not power an entire facility. So you would select different areas that or different vital pieces of equipment that you would use for something like this. Okay, the next one is an inverter. An inverter is a device that converts direct current, DC, into alternating current. An integral part of a solar panel, right? Because a solar panel is DC, and if you have appliances that you generally use AC, you need to convert it, right? So you use an inverter. Then you have a rectifier, which is the exact opposite. It converts alternating current into DC. Okay, so it's just the opposite. So you have something that was designed for one power, and you need to use it for a different one. You can use either of these devices to do so. All right, let's talk about a transformer vault. We already did talk about a transformer. A transformer vault is an underground vault that houses a transformer. These are often found in sidewalks outside of urban buildings. So basically, when you walk over that thing that says AT&T or something like that, or owned by the power company, maybe not AT&T, that would be telephones, right? But owned by the power company, whatever, you're walking over some high voltage, right? So it's a good thing to know what those are, okay? So the next one is electrical demand. I mean, it sounds self-explanatory, but let's give you the textbook definition. The amount of electricity required during a short period of time, usually 50-minute increments. Demand is measured in kilowatts, okay? So peak shaving is a method of reducing electrical demand for short periods of time during peak generation hours, used to reduce demand charges in electrical bills. Boy, hard time with that one. We talked about those other pieces of equipment that does this. So this is just a way of saving electricity during peak periods. All right. Let's talk about the arc flash safety program. It's a mandatory safety program in the U.S. to prevent people from being struck by an arc flash, or an arc of electricity that can shoot out of an electrical panel of a piece of equipment. I'm not going to get into the details of that system or that program, but there is a program that is required, and all equipment must meet that standard. Okay. Now this is one. The next one is log out tag out program. I'm a big proponent of this. Electrical safety is a big deal, right? People can be hurt seriously or killed by electricity. Right? Now, not all electricity is going to kill people all the time, but a log out tag out program prevents people working on systems from being hurt. So, in your house, right? Maybe you're changing a light fixture or something like that. You're putting in a ceiling fan. So you go and you click all of the circuit breakers that are around there, and you double check and make sure it's done, right? Then someone else in the house goes, and so you're sitting there handling wires, hooking up your ceiling fan. Someone else in the house goes and tries to turn on a toaster or something like that, and it doesn't go on. So they go back to the panel and say, why are these off? And they click them on while you're holding it, right? And you don't know it, and you can get electrocuted, all right? That, I don't know why I laughed at that, because it's very serious, right? In your own home, you should do something by putting a sign on there, don't touch this, I'm working on electricity or whatever. But in a professional setting, when you have people working on things and they go and they turn off the circuit breakers, they trip a circuit breaker so they can be safe. What happens is it's very common for other people not to know that that's even taking place, and going and turning back on and then hurting somebody. So there is a system that OSHA requires. We talked about OSHA before. I believe we did in this class. Anyway, that's the government agency that handles occupational safety. Yeah, we did. Yeah, when we talked about communications. Anyway, so OSHA determined this, where in a professional setting, when somebody's working on something, they have to put a tag that says do not touch, whatever, and then should be a facility in professional or commercial operations where you can actually put a padlock on it so people can't click the click the breaker and then harms the workers, right? So that's what logout tagout is. Okay. I've always been very, very adamant about this because I've seen people get hurt, and it's a very stupid way for someone to get hurt, to be working on something and someone else did no better and they turn the power back on. That's a very dumb way to die, right? So let's make sure that we adhere to that in those facilities that we manage. Okay. So frequency is the next term we're going to talk about. It's the number of times per second that an alternating current changes polarity, measured in hertz. Different regions provide electricity at different frequencies, and which may affect appliance performance. So if you have an appliance that was made for the United States, it might not work perfectly in another country because of that, and also the voltage might be different and stuff as well. But frequency is important to know. Okay. So that's it for the definitions. So now I'm going to go to the homework, and we're going to make sure that all of the things that I'm covering on the homework, I cover here. All right. So briefly in the first definition, I talked about amps, volts, and whatever. All right. Whatever, ohms, right? Amps, volts, and ohms. What are they? Well, they are simply ways to measure different aspects of electricity. An amp, or ampere, but you can be spelled AMP, the correct spelling, or the proper spelling, the original spelling is AMPERE, is nothing more than a unit of measurement for electrical flow in a current, or current, how it flows, right? Volts is electrical pressure, the force behind the amps, okay? And then the ohms is the resistance. Okay, you have volts pushing the flow, right? But then you have things that resist it, right? Along the lines, the longer the lines, the more resistance you have, because there's natural things that push back on that pressure, all right? So we have amps, volts, and ohms, okay? So what is a watt? Well, a watt is is a unit of power. It's basically a unit of power that is the power companies have established as a way to measure usage, right? So how do you calculate it? You calculate by watts equals volts times amps. So you have that flow and you have that pressure, multiply those two, and then that gives you your watt. Okay, and then what's a kilowatt? A kilowatt is basically 1,000 watts. Anything kilo is 1,000, right? So kilowatt is 1,000 watts, and that is how, generally speaking, we get charged. Kilowatts or kilowatt hours is how we get charged for electricity. All right, so moving forward. Okay, so the next thing I want to talk about, and this is now things that we have to deal with as hospitality professionals. We're in a hotel, we're in a restaurant, and the electricity starts doing wonky things. We want quality electricity. That doesn't make any sense. We want quality food, we want quality products, materials, whatever. Quality electricity? What's quality electricity versus poor quality electricity? Well, let's talk about it. All right. So quality issues in electricity are going to be surges. That means there's too much voltage, and things that you might damage a piece of equipment because it's too much voltage for it. So that is a surge. Okay. A transient is an intense burst of high voltage. So that is something really, really. So it's like a surge on steroids, right? So that is something you definitely need to worry about. Okay. And that's going to probably damage some things. Okay. Sags. Now the sag is basically opposite of a surge. Where a surge is too much voltage, a sag is too little. All right. So that's an indication of poor quality electricity. Okay. So then we have brownouts. Now, a brownout is a sag that are 5% or greater drops in voltage. And they're actually, generally speaking, a brownout, when we use the term brownout, we're talking about things that are intentionally done by the power company to conserve electricity. They just say, you know what, we're reducing your quality. just as anything. If you get lower quality, you're paying less, right? And, so that's what they're trying to do, is they're reduce the usage, whatever, the drop in the quality. And sometimes you'll see power companies do that at certain periods of day or whatever. Okay, so that's a brownout. A blackout is a complete loss of power. We all know what that is. We've all experienced it. Unless you are the most fortunate person in the world who's never experienced a blackout, we've all experienced it. I mean, back when I was a kid, many years ago, they used to happen a lot. And so, and the funny thing is where I grew up, it wasn't that bad. It happened maybe 2-3 times a year. Then I went overseas to like England, and oh my God, in the 80s, in the late 80s and early 90s in England, it happened all the time, right? But we're getting better at that as infrastructure gets better or whatever, but that's a blackout. Okay, electrical noise. This is an interesting one as far as, it's not as intuitive as you might think, electrical noise. When I think of that, I think, oh, that hum that we hear. Yes and no. When we're talking about electrical noise, we're talking about what is causing that hum. And what that is static on the electrical lines, and it can affect equipment. It can affect, because static is more electricity than what you're anticipating and wanting and calling for. So it's definitely going to, has a potential of affecting things. Okay, so this was down and dirty. Basically, all I did is go over the quiz and the homework. That's it. So if you don't have a book and you are struggling with this, if you watch this video, you should be able to do your homework, okay, without any problems whatsoever. All right, I know that that's kind of outside the way I normally like to do things, or I like to explain things, but when some of these systems where they're just, basically we're just trying to get an understanding of certain aspects of it, I feel that this is the best way to do it, okay? So I'll see you in chapter 8.